Hey, well, welcome to the channel again, and I'm sorry about this microphone thing. I am talking right now, but the mic is not picking it up. What you're hearing is a voiceover. So I'm sitting here watching myself like a silent film, like the worst silent film I've ever seen in my life. I'm pointing at the speaker. I have no idea what I'm talking about, but I'm sure it's important. So I'm gonna kind of fill in the details here and just cut this intro short probably, but basically I am pointing at the tweeter there because I've got a 4 ohm Dayton reference tweeter and an 8 ohm reference mid-range. Now, I'd been messing around with resistors in series, and I didn't really like the way that turned out. It was a really wonky frequency response. It didn't seem so bad when I just had the resistor in front of the 4 ohm tweeter. Like I had a 4 ohm resistor in series with the 4 ohm tweeter to make it an 8 ohm nominal load. And that wasn't all that bad. But then I switched it up. I put a 2 ohm resistor on the tweeter, and then I wanted to bring the mid-range down a little bit and attenuate it. And so what I did was I put the 4 ohm resistor on that. Well, long story short is it still sounded good. Frequency response was all over the map. So what I'm gonna do now is put in some Zobel networks. So I'm gonna be snatching these resistors off of the back of these, off of the tweeter and off of the mid-range. I'm gonna be taking and building Zobels for every single transducer in there. So tweeters, mid-ranges, woofers. I found that by adding Zobels, if you do one at a time, it doesn't seem like one speaker at a time, it doesn't seem to have as big of an impact as putting them on each speaker on the network. All right, so long story short, I'm set up here in the room. I've got the speaker like about a third of the way into the room. It's probably got 6-7 feet on either side of it. The ceiling's 8 foot tall, got carpet, etc. So it's sitting in about the best place I can put it to measure it. And I'm measuring it from 2 feet away, just to get the mic a little bit closer to reduce any kind of weird reflections or diffraction. But I'm going to go ahead and run a sweep pretty soon here, and we'll take a look at it, and then we'll compare what it looks like after the Zobels are installed. So before I continue with this video, I want to take you back to February 5th, 2023. Video I did, it was a huge epic video, but basically what I was doing was I was fine-tuning my Jensen CS315 RestoMod speakers, and I utilized Zobel networks on an off-the-shelf crossover, and this is a short snip of that video showing the results.
Hi, welcome to Dr. Mix. This is a signal test for you. Enjoy.
So the Jensen CS315 RestoMod speaker project had its share of ups and downs as well. And what ended up really taking care of this frequency response for me was the use of Zobel networks on all the speakers, on all the drivers. So on this system, it worked pretty good. So that's the reason I'm going to try to kind of replicate that on the RCA STS 1230 project. Pretty crazy, huh? What do you think? Nice. It's come a long way. That is absolutely a plus minus 5 dB full range stereo speaker set. That's pretty cool. In-room response, untreated room, plus minus 5 dB. And I can expand this a little bit for you. Pretty good. So all the way from the lower end of the scale, 20, on over to, wow, what's that? 15,000, 100 something, well beyond my range of hearing. So pretty cool. And it's still got a little bit of extra left over there too. So if anything ever does hit up that high. Anyway, we've come a long way, baby. All right, now let's get back to the present video where I'm working on the RCA STS 1230. All right, so we're back to the present day on my current project, and what you see me doing here is basically just gutting the cabinets. I'm going to pull all these drivers out of here and install Zobel networks on them, put it all back together, and hopefully it will sound good and the frequency sweep will be good. Okay, well, I'm back. You're listening to me over the Pixel 7 mic because, lo and behold, I guess I have a short battery life on my lapel mic. Or maybe I just leave it on and I don't know it. But anyway, okay, so I hope that you can hear me. And I figure I'd kind of show you what I'm up to here to figure out Zobels. All right, so I've done a little bit of homework ahead of time. And typically what I do, well, I've got my values written down here that I need. And I saved them in an email, sent it to myself, and then wrote it back down. But basically, I'd kind of pre-planned on having Zobels on these speakers. So I did order a bunch of resistors and capacitors ahead of time, probably, a month ago or more. So what I use to figure these out, it's not super rocket science or anything. It is actually, I just go to DIY Audio. They have the Zobel Network Impedance Equalization Network Circuit Calculator. And it goes into detail as far as, you know, what it is and how to put it in there, but it's just got a simple calculator. And you plug in each driver's RE and LE, which gives you your capacitance and your resistance, okay? It's that easy. So you just look at your drivers, if you have the specs for them, plug those in, and now if you don't have the specs for LE, which a lot of times a speaker won't have it, if it's especially if it's a cheap speaker, that you're gonna have to kind of wing. The way I did it last time, actually, I had to do it on, I forget what it was. I want to say a Goldwood or a GRS that didn't have the specs. And so what I did was I found the closest driver I could to it, and then I compared that to one or two other ones and kind of figured out where they fell in as far as like a 4 or 5 inch speaker, where that fell in, and just kind of guessed at it. So this network is not ultra super critical. It doesn't have to be exact. The values that it comes up with are going to be sometimes pretty obscure. Case in point, like 2.13, 7.13, 2.36, and so on. Now, without buying 100 different components, you'd probably want to just get as close as you can to these values. So that's what I did. So what I need to do is, first, for the tweeter, I need to find, well, let's start with the woofer. The woofer is usually your biggest culprit that's going to need impedance equalization more than the other drivers. I found personally, now I don't know, everybody's mileage may vary, but I found personally that they do very little when you put them on just one driver. They don't do a whole lot more if you have them on two, but if you have them on three drivers, it seems to react entirely different. It seems to change the entire output of the speaker as far as frequency response. So that was my experience last time. I don't know if I can duplicate that or not. But basically the woofer, I need 24.6. That's the value I needed, the 24.6. So that's the first thing I'm going to try to find. Next thing I'm going to try to find is the 7.63, get as close to that as possible. I'm not going to bore you while I sift through my bag of parts here. I'll figure this out, turn back on the camera when I'm ready, okay? All right, so I've got all my parts figured out here. And in case you're wondering, that black hot glue from Parts Express, it's tough. I had resistors glued on the back of these drivers. And yeah, took a bit to get them off. This one especially, because I think it's, I don't know, I guess this is plastic, but boy, this stuff stuck really good. The tweeter, once I got it kind of going, it popped off, but not real easy. So if you're ever wondering whether or not the black hot glue from Parts Express holds well, the answer is yes. All right, so back to business here. So what I've done is I actually went so far, I had gone through this yesterday and put down the values that I needed, emailed them to myself so I had them, etc. Then I just went back through this Zobel calculator to make sure that all my measurements were right, that I didn't, miss something along the way. So I went back into, the Parts Express website and, looked up the different drivers that I have and plugged in those values into the Zobel network calculator just to verify what I have here is correct, that the numbers I have are correct. So when you're working with the capacitors and resistors, and for those of you who don't know, obviously, the ones that do, fast forward or something. But okay, so like I said, the Zobels, it's going to be hard to get it, right on the money, what these calculations come out to be. And whether or not there's a point of diminishing returns to that, I don't know. I'm assuming there is. I like to keep my components simple and as few as possible, if I can all help it, and affordable. Case in point, these capacitors here are like, the value on them is 22, all right? And these things, if you got a poly cap that was a 22, wow, it would be expensive. So anyway, when it's just something like this, like a Zobel, where this is simply it's like a bypass, essentially. It's not, you're not running, a signal through here to the speaker. It's just, it's equalizing that circuit is all it's doing. So I want to get as close as possible. So my value for the capacitor on the woofer is 24.6. I've got 22s, so that'll have to do, one per woofer. The resistor that it's calling for is a 7.63. Well, I don't have, I could probably get really close to 7.63 by combining resistors, but then you'd have a chain of resistors, because with resistors you need to, add them in series in order to make an accumulated value. So in other words, if you had, two 4-ohm resistors and you put them in series, now you have 8 ohms, okay? If you put them in parallel, you're only going to have 2 ohms. You split that in half. So that's the math on that. Capacitors work just the opposite. When you put them in parallel, well, they don't work exactly the opposite, but as far as adding capacitors together to make a value, you would put them in parallel. So for example, on the woofer, going back to that, sorry. So I'm just going to use a 22 in place of the 24.6. And for my 7.63, I'm going to just go with an 8 ohm. The resistors that I'm going to put on here, I'd actually bought them for something else, different project, but they're 50 watt 8 ohm resistors. And being that it's going to be, the majority of my power is going to be going to that woofer, I prefer to have something a little beefier on there. So I've got a 50 watt resistor that's going to be there. Now for the mid-range, so this is where we get to combining capacitors. This is the fun part. So we've got 2.36 that it's calling for. And the values that I have here that are close, I've got a 1.5 and a 1.0. All right, so by putting these, 1.0. So by putting these in parallel, what I wind up with is 2.5, which is pretty close to what I needed. Okay, so we've got that. And I'm just gonna kind of twist them together like this, and then I'll wind up soldering them. Got the solder gun, it's already hot. It's been sitting here waiting for me. All right, and then with the resistors, it's calling for 7.13. I've got a couple of 7 ohms here. These are only 10 watt, and I was really kind of thinking I would use a bigger one on the mid-range, you know, like at least a 20 watt. But then I'd be jumping the resistance value up to 8, which is like, you know, I'm trying to round to as close a value as I can. So I'm going to just kind of trust that these are going to hold up for me. I think they will, actually. I believe it's the 10 watts that I'm using in my big Jensen speakers on the mid-range. All right, now for the tweeter I could have used smaller resistors, except I don't have any in the right value. So it's calling for 3.75 ohms. And the closest I can get to that is a 4. Like I say, I could reduce that number down by combining these in parallel. Get a little bit closer, but I think that it's going to be diminishing returns on that too. As far as the capacitor goes, it's calling for a 2.13. And what I've got here is a couple of 2.2s. So I'll use a 2.2 instead of a 2.13. Anyway, that's how I'm calculating the Zobels. It is not exact. As you know, my science is very flawed. This is amateur pseudoscience going on here. A lot of trial and error. I know a lot of you rip on me for it, and that's fine, man. I kind of dig experimenting, see what happens. Not that I don't like to have a good basis for my decisions, but when it comes to something like this, I'm not going to have paralysis by analysis. I think that, you know, getting close enough is going to show me some type of result. It's going to change the behavior of these drivers with that crossover, and it'll change that frequency response. It'll modify it some. To what degree and whether it's good or bad has yet to be seen. So I'm going to go ahead and get to work on getting these Zobels on the drivers, and then get them back into cabinets, and then turn them on. Probably listen to them a little bit, let them warm up, and then go ahead and sweep them with the frequency response graph and find out just what we have. All right, so here's what I got going on so far. I forgot to show you. I've got my Zobel put together for each of the speakers. This is the mid-range. This one's for the woofer. and this one's for the tweeter. Okay, so now these go between these two terminals like this, actually like this. The capacitor goes on to the positive side. Now, the thing is with this is that I want to be really quick when I solder this, because this one here, I've got to solder it onto the tweeter. And so I'm going to be real quick about it. I don't want to overheat this tweeter. Pop that on there. And then, same thing with the mid-range, is I'm going to have to just do a real quick hit with the solder on there, just to get it to make contact and stick and touch. I'm not overly concerned about how great that connection is, because again, it's just a bypass. On the woofer, I have a little more latitude, and I can actually put terminal ends on these, because the woofers have, you know, 2 sets of terminals on them. So that's what's going on with this. Now the other thing is, with this 4 ohm tweeter that is such a pain in the keister, because I don't know why they didn't make an 8 ohm reference tweeter, right? Well, anyway, it is what it is. And so what I'm doing is I'm using the impedance equalization for the tweeter based on the tweeter's, you know, parameters. But I still have to make it an 8 ohm tweeter, right? So I'm going to have to put a 4 ohm resistor in series with the lead on it. And I know that, you know, there's some concern that this could knock down or attenuate the tweeter too much, but I'm willing to take that chance right now, because the graph that I ran previously, when this tweeter had the 4 ohm in series with it, it matched up with that mid-range really well. So that's what I'm counting on. More so a seamless flat transition, even if it does roll off, say, you know, by 10 dB by 15K, it's good to have the majority of that that treble. It's good to have that treble as flat as can be. Once it gets past 10,000, I mean, that's up there. That's pretty high. 12,000, I can't barely hear it anymore. So I'm not super concerned about it rolling off at the very top like that. The main thing I want to try to achieve is a nice flat region across the majority of where music is going to be played at. So the majority of vocals, the majority of musical instruments, you know, are all in, say that, well, the majority of them, the bulk of them are probably, say, between 60, maybe 80 on up to, say, 10 or 12,000. Yeah, so, you know, on the low end, figure 50 hertz. On the high end, figure 15,000 hertz. That's where, I mean, it's very rare that music is going to produce bass below that. It's very infrequent that it would go way up high. And even if it did, you wouldn't hear it anyway, or I wouldn't. So, all right, so I'm going to get busy getting these things on the drivers and then throw them in there. I just wanted to stop and kind of explain what is happening at the moment. Well, that was a lot more work than I expected it to be. Man, I'm telling you what, I probably should have just waited. I have a couple of regular viewers who offered to send me some designs for crossovers that you know, I can go ahead and buy some components for and build crossovers for these. So I probably should have waited, but I wanted to find out if I could tweak these things and make them sound better right now. And on my last set of big speakers, big three-way speakers, what I used to accomplish a much better frequency response and sound was I employed Zobel networks or impedance equalization circuits on each of the drivers. It didn't seem to make a huge difference on like a single driver, because I did try it incrementally on those other speakers, like one driver, then another driver, and finally I wound up with all three of them. Now when I put all three of them on there, for whatever reason, it made like a world of difference. I don't know if that will happen again. I don't know if it'll, you know, repeat on these or not. But the biggest reason I wanted to kind of give you a shout out here is that one thing about this channel that's a little bit different than a lot of the channels you see is I tend to put myself out there. I'm living my mistakes, and you're seeing my mistakes as they happen. You viewers, you're kind enough to put comments in there, suggestions, constructive criticism and stuff to kind of help redirect me or guide me or give me some wisdom. So that's really cool. I appreciate that. As far as like if you have questions and stuff, like I can absolutely answer questions too to the best of my ability. I don't plan to be, you know, an audiophile, even though these speakers, I'm thinking that they're turning me into one. But yeah, I don't plan on using those big fancy words anytime soon. And as far as like, you know, being a speaker, pro builder, designer, that's not me. I mess with old speakers. 20 plus years ago, I was really into building speakers, the cabinets, crossovers, the whole 9 yards. But honestly, I'm just not, I've got a, you know, full-time job that takes up way more than enough time. And so I just pretty much do this as a hobby right now. But my point is that I like to share my experiences for the very first time with you guys, whether they're good and I give it a thumbs up, or whether it's an epic fail and it's a thumbs down. I want you guys to see it with me. That being said, my Zobels are installed. They're not the prettiest things in the world. Didn't go as smoothly as planned. Nothing ever does, right? But they are installed on all the drivers. I have got a 4 ohm resistor in series with this 4 ohm Dayton reference tweeter. So it is a nominal 8 ohm system right now. The load that it's presenting to the crossover should theoretically be, you know, an 8 ohm load. So the crossover should work properly. You know, I'll be able to see when I run some sweeps. First things first, because I'm old school and I believe in burn-in. Yeah, sorry. I know some of you guys do, some of you guys don't, but I think it's a real thing. So anyway, first things first is I'm gonna see if these things even work anymore. Man, I'll tell you what, I'm a little bit nervous about it because I absolutely hate soldering on speakers right on the terminals, because they're usually mounted to plastic and they've got a really tiny like little wire connected to that terminal. They're not really robust. So man, I hate soldering on those. And sure enough, you know, as I'm soldering them on the tweeter especially, it's got to be the tweeter, right? This expensive reference tweeter. Sure enough, you know, the terminals are wiggling around on the hot plastic and everything, and I'm like, oh no. So I don't even know if they're gonna work anymore or if they're gonna sound right anymore. One thing I always kind of wonder about is like when you solder onto a speaker, I would assume that heat goes racing through that coil really quick. So I don't know if it can mess up the coil, if it could burn out the ferrofluid. I don't know. I've soldered on speakers in the past and it's worked out. I don't think I've ever had one that like blew from soldering, but that's not to say it isn't possible. And I'm not the best solderer in the world. Most of my soldering was back from working on cars and industrial machinery, so that's more the scale of stuff that I am accustomed to soldering. Speakers, on the other hand, they're really hard, man, because you got kind of thick wire, right? And it's going to have some length to it. Or if you're putting on components, soldering on components like I was with the Zobels, you've got a resistor in there, you've got a capacitor. Those things suck up heat, and it takes a bit to get the metal hot enough to get it joined, you know? And so it gets hot. I do not like that. I would much rather have a mechanical connection any day. Yeah, well, anyway. So what I've got to do now, I've been listening to I've been playing music in the background on some audiophile speakers, like literally audiophile speakers with an F, not a PH. And so my ears are kind of used to those right now. I'm going to go ahead and turn the system off, disconnect those speakers, reconnect these speakers, turn it back on, and fingers crossed it's going to work. I'm going to hear something out of it, and then I can listen to it and probably listen to it throughout the day, and then take some measurements once they're all, I feel like they've got some run time on them and they are you know, burned in. Okay, so all right, that's my spiel. And yeah, I hope you could hear me talking. This is going over the Pixel 7 mic. I know that there's some, that's not always the best thing, but anyway, at least you can hear the music through the Pixel. It doesn't sound right coming through a lapel mic. So all right, here we go. You ready? Oh boy, getting old. Yeah. All right, turn that guy off. Disconnecting the left speaker and reconnecting my STS 12-30. Come on, baby. Work for me. All right. Yeah, so in all honesty, you know, I've not turned these on yet. Like, I just finished them like 20 minutes ago. Okay, here we go. Ready, set. Come on. Let's see what the volume is at. -30. Okay, so I should be able to hear it when I turn on some music. This is that fancy royalty-free music that you've probably never heard before and doesn't always sound the greatest, but there's no copyright infringements on it. Here we go. I hear something.
Hi, let's go.
Alright, let's take the Patera weather forecast today.
Today's forecast, a lot of sunshine, blue skies, marine clouds. Just a perfect day to go outside and relax.
Okay.
That's your forecast. We'll be right back.
Yeah, sunny days, sunny days, sunny days. No clouds in the sky, but again, the wind feels like it's been a freaking
Well, the drivers are working. That's good. Yeah.
all the stress and doubt, yeah, not today.
Let's turn it up to -15. I'm I'm actually surprised that they're working. I'm happy they're working. I was expecting the worst. I have no idea what this is, but let's listen to it. I would tell you I know what instrument that is, but I don't.
Took a chance on a good thing, yeah. Now I got you on my right wing. Making love, now it's casual. And you text me in the morning, you're available. Am I dreaming? Can't believe I forgot this feeling. Finally found the one in my life that I wanna be with. No more seeking. I'm sure I'll always choose you first.
Sounds pretty clear. It's still exhibiting the really razor sharp imaging like it did before, so that's good. I can tell mid-range is a little bit louder, but it doesn't sound as harsh as it used to. At least not what I remember it. Wow, sounds pretty good actually. All right, well, I'm going to listen to it a bit, several hours, then do some sweeps and see what we got.
Put your trust in me. Hope I won't let you down. Give me a chance. I'll try. See, it's been a hard road.
That's our old frequency graph.
If I take your hand, might lead you down the path to Rome. Had a hard life. Just sing it so you'll understand. Oh, right now, doing the best I can. This point in my life.
All right, well, the speakers are, put back together. I've been listening to them for several hours now. I've got the OmniMic software set up. I've got the speaker in the same location that I had it the last time I measured it. I've got the mic 2 feet away on center with the just below the tweeter. Let's see what else. It's the exact same place it was in my previous video. All right, so right now I've got Zobels on here on each of those speakers. I've got a 4 ohm resistor in series with the reference tweeter. And the mid-range is just reverse polarity, no resistor in series with it or anything. To me, the mid-range still sounds a little bit bright, but it still sounds really nice. Whether or not the Zobels improved it or not, you're about to find out at the same time I find out. All right, so here we go with this measurement thing. So let's clear this out. And first we have to establish a 50 hertz tone. That's what I've been using for setting the datum. Make sure this volume isn't crazy loud. Yeah, it was crazy loud. Okay. All right, so this is going to be 50 hertz. All right, and let's go ahead and establish a decent baseline here, datum. And if I remember right, yeah, so there's negative 60 dB at 50 hertz. Yep, negative 14 dB on my receiver, which is exactly the same thing that it was the previous time I measured this. Now, where do we want to set our green line at anyway? Well, I don't know. I'm kind of interested to see what the bottom end is like. It should reach to about 40, 39, 40. Let's do a full sweep, a long sweep. Okay. Very interesting. Yeah, wow, I could tell you already. It definitely leveled out that mid-range and treble. Absolutely. Wow. This whole area in the middle is way better than it was before. That's pretty interesting. So far, so good. What else we got on here to check? Let's try a short sweep with no bass. I'm not exactly sure what the difference is with short sweeps and long sweeps and that, other than the fact that I don't think it loads up the room as much. Let's try a bass sweep. And the speaker is a good 13, 14 inches off the floor. Oh, not too bad. I mean, if we use this as our baseline, like this, say, negative 70 line, I'm thinking it looks pretty decent. We're not quite at 38, more like 41 hertz on the low end. But it's got a pretty nice bump on the bottom end, which I kind of like. Bass is the first thing that dissipates as you move further away from your speakers, or the bigger your room gets, or the further away that the speaker is from the wall. So that's pretty good. This is about 3 feet away from my back wall, sitting about a third of the way into the room as far as front to back, and then side to side it's almost even with probably 6 to 7 feet on each side. And these are 8-foot ceilings, carpet. Not a whole lot else going on in here other than the junk you see. All right, what else you want to try? Let's see what else we got to try. Pseudo noise. I don't think I've ever tried that one. What's pseudo noise? Ooh, that's nasty. I wonder if that's supposed to fill up the whole thing. Let's see. If any of you know what pseudo noise is supposed to be for, let me know. It looks to me like it replicates the entire frequency range. Yeah, I'm real good at this stuff, ain't I? I'm thinking pretty good. I think the Zobels actually did improve it. Pretty wild. At this point, whether or not I need to rebuild the crossover, I don't know. I'll have to listen to them some more, but I'm thinking probably not. Not unless something funky goes on. But right now they're sounding pretty good and they're measuring okay. Not as quite a low budget project as I had originally intended on, and definitely I've spent more time on it than I ever expected I would. But in the end, it's a pretty decent speaker. Like I said, it kind of made an audio file out of me. I was hearing things I'd never heard before. Pretty cool. All right. Thanks for watching. I hope if you landed on this video and you like it, that you subscribe, get some notifications going with that little bell. If you're already a subscriber, thank you so much. I really appreciate it. I really enjoy all your comments. I try to read all the comments. I try to reply to the ones that, you know, have something to reply to. Yeah, I just really appreciate you. I'm glad that you're here with me. This is a passion of mine, just working on these old cheap mass market speakers, doing vintage RestoMods. So vintage RestoMod speakers. At least that's what I'm doing right now. I also enjoy messing with the exciter speakers. Maybe I'll park these for a while and just listen to them and start working on an exciter project. All right. Well, thanks again.